Hi everyone, my name is Matt Kafker, and I have a planned speech here, but I just wanted to say something before I get into that. It's been since 2019 that I've come and been back on campus, and this is my first hour back on campus since then. It's really beautiful to be here. We have a lot to be grateful for, and I look forward to the next time that we can be together in this atrium. So anyway, here's the scripted speech, and thank you for coming virtually. I believe that a good speech should attempt to explore a genuine question. Given that we are reaching the end of our college experience, the most relevant and worthwhile question I could come up with is as follows. What are the most useful lessons I've learned during my time at the University of Oregon? In trying to answer this question, I've looked back at the 3 years that I've spent solving problems and doing research in the physics department here at UO and tried to derive the most useful lessons I could. I'm hopeful that their utility extends beyond physics. Perhaps you will find something useful or at least entertaining in my observations. Lesson 1, each failure contains useful information. You do not succeed in the physics major if you're not comfortable with failure. Questions in physics have right and wrong answers, so when you are wrong, you are wrong. Physics is unforgiving in this way. Each week, our classes and labs present us with new, difficult problems, and so, each week, we are forced to contend with precisely how much we understand and how much we don't. If you don't understand what is going on, you simply will not be able to solve the problems you are given. When you have been working hard in a class, the feeling of complete bewilderment when confronted with the newest set of problems can be exasperating. Inevitably, though, once the exasperation begins to fade, your only option is to throw out some mediocre solution and see what happens. Almost certainly your idea won't work. However, you can often see why it didn't work and then propose something else that may avoid that problem. Your second proposal will usually fail too. However, by iterating on this procedure, you can usually navigate towards robust solutions to difficult problems. By exploring many dead ends along the way, you will be able to appreciate why a solution works when you eventually find it. Over time, this process will allow you to better appreciate the difference between strong reasoning and poor reasoning. So failing can be quite useful. However, some failures have higher stakes than others. To fail on scratch paper is one thing, but it can be far more distressing to fail on a test or a project or something larger. These failures can be extremely discouraging, especially when we try our best and see no results. Nevertheless, I've always found it to be the case that once I've processed the initial wave of frustration and disappointment, I have new information that I didn't have before, useful information. None of my classmates would be graduating today if they did not have a healthy relationship with failure, even major failure. We fail every day, but those of us who have thrived have learned to use that failure as a tool. Lesson 2, do not underestimate the value of a good question. One discovers quite quickly in physics that complex problems tend to have many valid solutions. There are many ways to skin a cat, as the saying goes, even in the highly rigorous field of physics. This state of affairs can be both a blessing and a curse. Sometimes circumstances will dictate that you have to use someone else's approach, which might be awkward or frustrating. The blessing, however, is that you often have much more freedom than you think you do, and you can use that to your advantage. More frequently than you might think, you can use this freedom to reformulate problems in a way that makes sense to you. Each of us has our own intuition and perspective. Accordingly, we each approach problems in a different way, with a set of tools we prefer to use and a set that we don't. And so, when something doesn't make sense to me, I often find it useful to ask my professor or my classmates to reformulate what they're saying in a language that makes more sense to me. Once we have recast a problem in a language I'm comfortable with, I'm much more likely to understand what's going on. Moreover, it often happens that others' questions help me understand something I had missed, and that my questions help someone else understand something they had missed. So do not underestimate the value of a good question. More often than not, we do not have to sacrifice our own way of thinking about problems, so long as we get where we need to go. In addition, if someone has found a completely different method of solving a problem, ask them how they did it. You may learn something you don't expect. Lesson 3, polite disagreement makes you strong. My friends and I work on physics in groups. Given that physics is usually pretty difficult, it often happens that someone believes they have solved a problem and it will emerge that they are not correct. Or perhaps they are correct, but they have not articulated their reasoning precisely enough to convince others. This necessarily means that we must be able to disagree with our friends and express our disagreement constructively. I frequently find myself in situations where I think I'm so clever for coming up with some solution, only to have a friend point out the terminal flaw in my argument. Other times, I am the one who points out the flaw in someone else's argument. Given that we have spent many hours each week working on problems together, we have had to learn to admit that we are wrong when we are wrong and to move on without holding a grudge. On the other hand, occasionally one of us will be right when our friends are wrong, and so we have also had to learn how to inform someone, maybe everyone, that they have missed something. In physics, you may be right today, but you will be certainly wrong tomorrow, or if not tomorrow, next Tuesday. So we have all had to learn to admit defeat with grace and to be reserved when we are correct. The next mistake is never too far away. I'm very fortunate in that my classmates have also become my close friends. Being able to disagree with my friends has made our friendship stronger. It has also made us better scientists. Lesson 4, there is no getting away from writing. Embrace it. Some days I joke that I chose to major in physics because we don't have to write essays. Writing is not one of my favorite activities. And given that most of the work in the physics major comes in the form of problem sets, when I do have to write, it is like going to the DMV. It is extremely unpleasant, it takes all day, and at the end I have a mediocre piece of paper covered in words that I don't care about. Over the years, I've required major help with my writing assignments. This unfortunate role has usually fallen on my parents, but recently I've started to terrorize my girlfriend, KAIA Hall, and my PI, Tristan Ursell, each time I have a deadline approaching. In spite of all this suffering, I've reluctantly come to believe that writing is an indispensable tool. Indeed, 2 years of academic research have convinced me that writing may be as useful as mathematics for a physicist, and it is considerably harder to do well than mathematics in most cases. In applying for jobs or graduate school, writing up your research, or simply organizing your thoughts on a complex topic, writing is your most valuable tool. And much as I hate to admit it, it is much more likely for future professions that we will need to write more than we need to use mathematics. As the department restructures the major, I encourage them to hold our feet to the fire more with respect to writing. Many of us could use all the help we could get, myself certainly included. There's no getting away from writing. Embrace it. Finally, Lesson 5, being surrounded by kind and creative people makes all the difference. I chose to major in physics because I love it. I think I probably would be studying physics if I were at any other university in the world, and I probably would have had fun doing it too. But I'm very grateful indeed that I got to study physics here at the UO, because our community here in the physics department is truly extraordinary. For the first few months I was here, I did not know many of my classmates, but they have since grown into dear friends. This has made my time at UO vastly more fulfilling and fun than it otherwise would have been. We are very lucky to have an enthusiastic and capable cohort of students and talented professors. We are very lucky to have an enthusiastic and capable cohort of students and talented professors willing to teach, advise, and mentor us. Last year, I had a minor crisis of faith when trying to decide whether I wanted to pursue a career as a physicist. To remedy this situation, I asked a number of professors in the department why they decided to follow this particular path with their lives. One response in particular stuck out to me, and I hope that Professor Graham Cribbs will permit me to paraphrase him here. He told me that you come to physics because of the ideas, but what keeps you here is the people. With the benefit of a bit of time, I could not agree more. When I decided to study physics, I did not know I was electing to join such a highly creative, kind, passionate, and interesting group of people. I'm very grateful for the community I found. As a final observation, this pandemic may have disrupted our final quarter, but it cannot take away the memories and friendships I've made here at the UO. And it cannot take away my gratitude for having gotten to spend 3 highly meaningful years with these wonderful people. If you will indulge me, I would like to show you some of our community so that you may see for yourselves why I'm so proud to be a part of it. I have asked my friends and professors to tell me what drives them, what they're passionate about, what brings them meaning. I hope that their thoughtful range of responses will help to remind us all why it is that we choose to dedicate our time to this fascinating and beautiful science, and why we are so lucky to do it here at the UO. Thank you for listening. Many congratulations to the graduating class of 2020, and with that, I give you my far wiser and far better looking colleagues.
So Matt, you asked me what's my life like outside of physics, or what do I like to do? And I like to play music. Particularly, I like to play jazz. This is a Jet song by, Leonard Bernstein, but actually Oscar Peterson and all playing it.
Hi, this is Professor FREY. What am I passionate about? Well, in science, I really am passionate about putting together different pieces of fundamental physics, like quantum physics and gravity, or black holes and dark matter, or gamma ray bursts and dark energy.
Hi everyone, this is Matt. You're currently looking at a robot that I put together with my girlfriend KAIA. By any objective metric, this is not a very impressive robot. It's supposed to avoid walls, but as you'll see, it doesn't do a very good job of doing that. The reason why I'm sharing this with you is because one of the things that I really love is learning new things, and I learned a lot putting this together. Another thing that I really love is silly things, and if you look closely, you'll see that the robot actually has a mustache. That's the type of thing that really makes me laugh, so I found this project quite meaningful and a lot of fun.
I think the most precious thing that I've encountered since I've been at the U of O has been the fact that I've made some very endearing friends in my life and met some of the most beautiful people in my life. And that's what's actually mattered to me the most.
I'd say that I'm passionate about my career for sure, but at the end of the day, what really gives my life meaning is my family. Whether that's the family that you're born into or the family that you've chosen along your journey.
These are some little crocheted creatures that I like to make in my free time. They make me very happy and allow me to channel my energy into something tangible.
To answer the question, what do I find fulfilling and what am I passionate about? I've settled on the answer that I am passionate about the transfer of knowledge. I feel very fortunate and lucky to be in a job where I can take the knowledge that I've gained through my career and share it, in particular with the students that I work with. I get to use facilities like Pine Mountain and to work at UO Physics, and I find those places to be the perfect vehicle to allow us to take this knowledge and transfer it to our students. And that's something that I'm feeling very passionate about right now.
There once was a man named Dirac, whose notation the theory did lack. Brazenquets he appended, ambiguity was ended, but I still hate his angle of attack.
Hi, Matt asked me to say a few things about what I like. I like video games, I like my kids, I like my dogs, I like to eat, I like my wife, I like to make stuff. So look at this. I made that. Oh, and I planted those.
Hello, class of 2020. Congratulations to a very hardworking, unique, and driven group of people. I admire each of you greatly, and I'd like to say thank you for all of the support I have received over the past 4 years.
And I offer you my warmest congratulations. You're a good group, and best of wishes to all of you. Congratulations.
Congrats, grads. Happy graduation. Do great things.